Good morning, Algebra 2 students. So today's asynchronous assignment is to learn how to formally do a linear regression. And what a linear regression is we're going to be taking data points and we're going to try and find an equation for a line that fits our data. And it goes nicely in Chapter 1. Chapter 1 is all about functions, and we have mainly focused on linear functions, and we've done a little bit with absolute value. Which is made up of, two lines kind of put together, and we've explored some relationships about functions, right? We've looked at how to describe them graphically, how to algebraically manipulate functions. So here's an example of what a line of best fit will look like. It will have lots of data, right? All those points are data points, and the line of best fit is the line that best fits the data. It goes through the most data. And if we look at some of these are stronger than others, right? Like if I'm comparing graphs, this graph up here looks really, really close, right, to the line, whereas this one there's a lot of points that are further away from the line. And when we talk about how strong the relationship, that's going to be the correlation coefficient, and we'll talk a little bit about that later on in the video. So right now I'm going to show you how to make a scatter plot and a line of best fit in Desmos. So part of this linear regression project asks you to find your own data. So I've already found my own data about how many forest fires there are in the state of California per year. And I'm trying to explore the relationship. My hypothesis is that as time increases, so do the number of fires. So I'm going to use my data and I'm going to see if that's true, and I'm going to see if that relationship is apparent. So what I'm going to do is in Desmos, I've opened up an empty page. I've logged in with Google so I can save it. I've called it Linear Regression Wildfires. And I'm going to make a table rather than an expression. Normally we add an expression. That's how we can type equations of lines. So I'm going to start typing in my data. So I'm going to start with the oldest year I found. I'm going to start with 2008, and that was 3593. So I'm going to pause the video to keep filling this in. Okay, so I have input all my data into my table. I'm going to make this full screen. I'm going to save it, right? You want to periodically save your Desmos graph as you're growing. Now notice I don't see data. That's because my data is way too big. So I'm going to have to do a lot of zooming to be able to see my data. Whoa, and there's my data. So I'm going to try and come over here. And one thing, if you're trying to get to the right space, but it's hard, if you go to the little settings right here, you're actually able to choose. So I'm going to make my x-axis, that's representing my time. I'm going to make it start at a little bit before 2008. So I'm going to maybe make it start at 2005. And I'm going to make it stop at 2020. Step is how much you go up each time, so I'm just going to say it goes up by 1 year. I'm going to make my y-axis. I'm noticing that, it's going up pretty largely, so I'm going to make it start at, let's try 0. I'm going to maybe make my step a little bit different. I'm going to go up to, it looks like my upper limit might be, I'll put 7,000 is close, and I'm going to make this step maybe like, let's see, if I make it 500, that might be able to see it a little bit better. So it looks like now I can really nicely see my data, which is great. So I'm going to take a little screenshot of this. So this is how I do my screenshot on my computer. You'll want to double check what the Chromebook screenshot is. So this is me taking my screenshot. I'm going to take a rectangular picture of this because I'm going to need to have my data and I want to have my graph for my presentation. And I'm just going to save it as my a picture on my desktop right now. So I'm going to call this wildfire data and scatter plot. And I'll deal with that later. So the next thing we want to do, I'm going to X that out, is we want to create our line of best fit. Okay, so our line of best fit, we're going to type an equation. It's going to be y. And then the next thing we're going to type is a squiggle. It's next to the 1. And actually, we want to make it not y, but y1. And when I type y1, it's referencing back this y1 from the table. And then I want to say I want a linear line. So I'm going to have a slope, right? A times x1, and then I'm going to do plus b. And so this is representing y equals mx plus b. The only reason why we have to have the little ones is because it's pulling the x values from here and the y values from here. So we want to be making sure that we're specific in how we type it. And then the a is representing the slope. The b is representing your y-intercept in y equals mx plus b. The little squiggle line is just how Desmos prefers to have it done. So you'll just have to remember that that's what you have to do it. Right, I'm going to maybe make a little note here that the squiggle is next to the 1. Right, that's how you find that. So looking at this, right, you're also going to want to take a screenshot of this. This is our line of best fit. If we look here at this specific data, what they're telling us with the A and the B, that's filling in your slope and your y-intercept for your equation. So my equation, my line of best fit, if I was typing this out on my PowerPoint, I would say my line of best fit is y equals 210, maybe I'll round it to 211, right? You can be as exact as you want. I don't really have a preference for how you round, so if you want to round to whole numbers, that's fine. So 211x minus, it looks like I've got a negative y-intercept, 419, 484. So notice that it's like really close to my line. If I wanted it to be exact, I would have to do 0.984. Oops. 211.9. That's weird. I don't know why it's doing that. Sorry about that, guys. I don't know why Desmos is being funny. So there is my line, right? It's really close to that line of best fit that Desmos found for me. So what that line is, this is an equation that we're going to be using in our project. So in our project, right, we're going to be analyzing what we find. So some of the things we're going to be doing is we're going to say what the line of best fit is. So I would physically right now type in my equation. So I would say, you know, if I'm typing it in as the student, I would say, okay, y is equal to 211x minus 419,484. Right, I would want to type that all in. That's my equation for my line of best fit. The other thing is we want to look for correlation coefficient, and it actually tells us what that is here. My correlation coefficient is R. And R, I'm going to type that here, and I'll explain what it is representing in a second. So R is equal to, what was it? I think it was 0.8 something. Looks like R is about 0.81. Okay, so I'm going to type that in. And what R represents, R is the correlation coefficient. That tells you how strong is the relationship between the variables. So if you have a correlation coefficient that is close to 1, that means it's a really strong relationship. So I'll maybe add a little note. Let's say a note. Strong correlation between the variables, right? And a correlation means that as one goes up, the other goes up. So that would be supporting my hypothesis. A strong correlation between the variables has the correlation coefficient R close to 1 or negative 1. Sometimes we have negative slopes, and that could be that the two variables that you're looking at don't both go up at the same time. So mine, I'm assuming that as time goes up, fires are going up as well. Something else that might have a positive correlation would be as time goes up, prices of movie tickets go up, that sort of thing. Sometimes correlation coefficients are negative. That would be as one variable goes up, the other goes down. Something that is easy to visualize is if someone is on a diet, maybe as time goes on, their weight is going down. Like that's an example that they always use for some reason. So that could be why your correlation coefficient might be negative. Okay. And so the big idea is if you're close to 1 or negative 1, that's good. That means your points are really close to your graph. Okay. So what we're going to be doing with those findings, you're going to be using your line, right? So here's my line over here. We're going to be using that line, that equation, to make some analyses. So my slope is 211. Okay, 211. I'm going to say that that's kind of like over 1, right? Your slope is rise over run. And let me see if I can real quick insert an equation. Don't think I can. Oh well. So your slope is your rise over your run, right? And so if I'm thinking about my rise, that's my y, right? So rise over run. Just gonna do that visually. So if I have my rise, that's my y value, right? My y value, if I look back at my variables, I've chosen my y value to be the number of wildfires. So your rise is your number of fires, and your run is your number of years. So what my slope is saying in words, this is what you'll want to be specific about, right? In the context of the problem, my slope means I would be saying that there are 211 more fires each year. That is how much it's rising according to my data that I've collected. And remember, my data isn't perfect, right? I don't have all of time. I have a very small data set. The more data you get, the better. I generally would go for, you want to have at least 10 good data points. And then you're going to do the same things with your intercepts, right? You're going to analyze your y-intercept. You're going to analyze your x-intercept. So what that would be, right? You can see your y-intercept in your equation. So my y-intercept is 0, comma, and I'm going to fill in my coordinate, right? It's that negative number right there. Negative 419,484. And what that means is that when there is time 0, there are a negative amount of fires, which doesn't really make sense in real world context, right? It's just that our line kind of keeps going, so that's what it means in context. So you would also want to find the x-intercept as well, your x-intercept, right? Visually on your graph. That is when I'm eventually going to, like, down here, hit that x-axis. Right, so that's when y is 0. So to find your x-intercept, you're going to want to set your equation equal to 0 and solve for x, right? That's what you're going to want to do. So set your equation equal to 0, solve for x, okay? And that'll help you be able to describe your findings using the real world context, right? So we're practicing using functions to talk about real life implications. Okay. And so what you'll do is you'll analyze your correlation coefficient. It seems like my correlation coefficient is like strong. It's not super strong, but it's like fairly strong. I would say, you know, if you're above 0.5, that means, you know, you're much better, like 0.7, 0.8, 0.9. Those are stronger relationships. If you're closer to 0.5, 0.6, you're not quite as strong. So this is where I would say that my R value is maybe 0.81, which is stronger, right? And then I would kind of go off to talk about, you know, what does that mean for my research? I might, you know, say that it seems like there's a correlation, but I might want to have more data. There's also a section where you're going to use that equation to make some predictions. And your predictions, you're trying to find a point using your equation. So I had very specific data, right? But using my line of best fit, I can make some predictions. I can say, okay, well, if X is blank, and I can make a prediction for what will happen in the year 2025, right? If I make a prediction for the year 2025, that is going to be called an extrapolation. And an extrapolation, all that means is, think about extraterrestrial, it's outside. That means that that data point, 2025, it's not in the data set I currently have. I'm extending into the future. If I wanted to make an interpolation, that's like inside of my data, I would have to pick a value that's somewhere in here. So for this one, I'm predicting a certain, let's see, I'm predicting a certain, oh, I think I switched that. I meant to do it like I picked my number X, so I'm just going to switch these. For here, I'm picking a number for Y and finding X, so kind of the opposite. So let's pick a Y value that is somewhere in our data. That would be an interpolation. So maybe I'm looking for 5,500 fires. That would be an interpolation. So I would look for 5,500.